Good morning, students. Keeping in mind that your exams are beginning from the 21st of November and first paper being Engineering Mathematics 3, making a video series for previous year questions topic-wise to help you prepare for your examination. So today's topic is complex numbers. We're going to solve previous year questions of complex numbers from the university papers. One thing to keep in mind is previous few years, because of the COVID time period, the direct second year students exams and the regular students exams are not conducted at the same time. So within the same year, there were multiple papers which students have appeared, and hence the number of questions is a little more compared to the regular exams. Okay, so let's begin with this and understand few techniques, and this is going to be your revision techniques. Okay, starting with the first question. F of z is given to you, and it is said that f of z is analytic. They expect you to find the values of A, B, C, and D. This question was asked for 5 marks in December 2022 examination. So let's understand the technique to solve this. Before we start with the technique to solve this, we need to understand the concept which will be utilized here. Now, since f of z is given to us as analytic, therefore it satisfies Cauchy-Riemann equations. Now, if you who have forgotten Cauchy-Riemann equations, let's revise them. So this implies that ux is equal to vy and uy is equal to negative vx. Now what is ux? What is vy? How to calculate them? Let's understand that. When I say ux, before I start with ux or uy, I need to first find u and v. So let's understand u is the real part of f of z and v is the imaginary part. So when I say real part, it will be the term which is without I. You can observe the question here. This is the term without I here in the question. So let's write it down here as ux cubed plus axy squared plus bxy. B is a term which is attached with I. So 3x square y, cx square, y square and dy cubed. Once we have identified u and v, we will be calculating ux, uy, vx and vy. So let's understand what are these terms and how do we calculate them. Now to calculate them, ux calculate करते वक्त ये याद रखना है कि x is the only variable. बाकी सारे जितने भी terms हैं वो सारे के सारे constant treat होंगे. So if you look at u, you have x, you have a, you have y, you have b. So x को छोड़ के everything else will be constant. Okay? And when you're doing uy, same concept, but now this time the variable will be y. Okay, I hope this is clear. So let's understand this with the help of this example. So because x is a variable, the derivative of x cube will be normal formula 3x square. The second term x is multiplied by ay square. So ay square is constant multiplied by derivative of x, which is 1. Here again I have a multiplication by x. Vy is a constant. Multiplication by derivative of x is 1. It's same concept to vx. X square is multiplied, so 3y is constant. 3y. Yeah. And derivative of x square is 2x. C is a constant. Derivative of x square is again 2x. Last two terms both do not have x at all, so their derivatives will be 0. Derivative of a constant which is not multiplied by variable is 0. Okay. Let's start with uy now. When I'm talking about uy, y variable होगा, बाकी सब constant होंगे. ठीक है. So x cube which is alone, एकलौता constant है, variable नहीं है, साथ में 0. Second term में y square multiplied है, तो ax will be constant. मल्टीप्लाइड बाय डेरिवेटिव हो जाएगा y स्क्वायर का 2y, bx कांस्टेंट, y का डेरिवेटिव 1. In the term of b, 3x square will be constant, derivative of y is 1. cx square का डेरिवेटिव 0 बिकॉज वहां पे y नहीं है. y स्क्वायर डेरिवेटिव 2y, dy cube का डेरिवेटिव d times 3y square. We have not simplified, we'll simplify it later. Okay, so let me call the Cauchy-Riemann equations as equation number 1 and substitute these values in equation number 1. So I would say from equation 1, we'll substitute the values there. So first part of equation 1 is ux equal to vy. So let's take down these two values there on the next page. So I have 3x square as ux plus ay square plus by equal to vy is equal to again 3x square, 2y and 3 dy square. So we'll first simplify this and then we'll move on to the second equation. So we are using only ux is equal to vy here right now. Let's compare the terms. Left hand side has a 3x square, right hand side also has 3x square. So I'm going to cancel both the 3x square. So let's cancel them. So 3x square on both the sides gets cancelled. Left hand side, I have a term with y square. Right hand side also has a term with y square. And there is a term with y here. There's a term with y. So when you compare, I'll have ay square should be equal to 3 dy square. And by should be equal to 2y. Which implies y square gets cancelled in the first case. So a becomes equal to 3d. And b becomes equal to 2. Y gets cancelled. So I found the value of b. Your question is to find the values of a, b, c and d, all four. Okay, we found the value of b. So again, let's apply equation number 1. This time the second Cauchy-Riemann equation. The second Cauchy-Riemann equation is uy is equal to negative vx. So let's bring those values here. Uy would be 2axy plus bx. And negative vx, let's see that. So it's going to be 6xy and 2cx, but both will be negative. Because of the minus sign with vx. I hope you have copied down the correct terms. Yes. Okay. So now let's compare the variables. Left hand side has a term with xy. Right hand side also has a term with xy. Here you have a term with x. And here also you have a term with x. So I have 2axy is negative 6xy. 6x is equal to negative 2cx. This implies 2a is negative 6, which means a is negative 3. We also have 6x is negative 2cx, so x gets cancelled. So negative 2c is equal to 6, which implies c is also equal to negative 3. The question is to find a, b, c, d. We have found a, b and c. Let's use the relation between a and d. Let me call this as equation 2. And let me continue on the next page. So from equation 2, a was equal to 3d. And we have found the value of a as negative 3. This implies d is negative 1. So we have found a, b, c, d, all four of them. And yes, that's how you solve your equation. I hope the question is clear. The question had given us that f is analytic. And we were supposed to find the values of a, b, c and d. Okay. So yes, that's how you tackle this. To understand it more better, I have taken a similar example from February 2023, again a 5 marks question. So let's quickly indulge into the same question. As before, we'll start with f of z being analytic. So this implies it satisfies Cauchy-Riemann equations. Which implies ux is equal to vy and vx is equal to negative uy. I think before I wrote uy is equal to negative vx, one and the same. So let's start again with u. As we discussed before also, u is a term without I. So ax raised to 4, bx square, y square, cy raised to 4, dx square, negative 2y square. That's my u. We'll go into the calculation of v little later because you can see it's a big one. We'll first finish ux and uy. Okay. And we'll say this is a real part. We'll say this is a real. Okay. So let's begin with ux. While taking ux, as we had discussed, x will be the variable, everything else will be constant. If a constant is multiplied by the variable, then we'll keep the constant as it is and multiply by the derivative of the variable. If the constant is alone, the derivative will be 0. So a, which is multiplied by x, remains as it is. 4x cube is a derivative of x raised to 4. By square remains as it is, 2x here. Cy square is constant alone, so 0. There is no x term there, okay? D times 2x, and there is no x term here, so 0. We may just simplify this here itself. So I have 4ax cube plus 2bxy square plus 2dx. Let's move to uy. Treating y as a variable and everything else constant, the first term will give me derivative 0 because there's no y term there. Second term, bx square as it is, 2y here, c as it is, 4y cube, 0 because there's no y, and 2 times 2y. Let's simplify. 2bx square y plus 4cy cube minus 4y. Okay, so you got ux, you got uy. We now move on to v and vx and vy. So let's write down v here. V is equal to the imaginary part, the part which is with I. So 4x cube y minus exy cube and 4xy. 4x cube y, exy cube and 4 times xy. This is the imaginary part. Let's calculate Vx and Vy. Again, when you're calculating Vx, x is a variable, 4y constant, 3x square is a derivative of x cube, ey cube constant, derivative of x is 1, 4y is constant, derivative of x is again 1. On simplification, I'll get 12x square y, negative ey cube, and 4y. Let's move on to vy. So when we calculate vy, y will be the variable, everything else is constant. So 4x cube as it is, derivative of y is 1. Ex as it is, derivative of y cube will be 3y square. 4x as it is, derivative of y will be 1. So 4x cube, 3exy square plus 4x. Okay. Once we got all of this, again, like the previous sum, we'll use Cauchy-Riemann equations. So let me call this as equation 1. So I'll say from 1. Okay, let me continue here. First, I'm using ux is equal to vy. So ux is 4ax cubed plus b 2bxy squared plus 2dx equal to vy is 4x cubed 3exy squared and 4x. Let's compare the terms. X cubed terms, xy squared terms, and x terms. So when I compare, I'll have 4x cubed is equal to 4x cubed. 2bxy squared will be equal to negative 3exy squared. And 2dx will be equal to 4x. This implies 4x cubed gets cancelled. A is equal to 1. 2b is equal to negative 3e. And 2d is 4, which gives me d is 2. So we found the value of A, we found the value of D, we found the relation between B and E. I'm calling the relation as equation number 2. Let's use the second Cauchy-Riemann equation. So again, from equation number 1, we have ux as negative vy. Let's substitute the values. Okay, sorry. It's uy, which is negative x. Okay, getting back here. Uy is 2bx square y 4cy cube minus 4y plus 4cy cube minus 4y. Negative vx would be negative terms applied here, negative 12x square y. The e term will become positive, so plus ey cube and negative 4y. Again, let's compare x square y term, x square y term, y cube term, and y term. So this gives me 2b is equal to negative 12, cos is e, and yeah, negative 4y is equal to negative 4y doesn't make sense. Means not required actually. It's actually equal. So b is equal to negative 6. Now let's see what we had found before. We had some relation between b and e. Now we have a relation between c and e. Okay. We have a relation between BE and we have a relation between CE, and we have found B here. So let's substitute this in equation 2, and let's keep this as equation 3. So equation 2 gives me 2B is negative 3E. So 2 times B is negative 3E. The negative sign gets cancelled. 12 is 3E, which implies E is 4. I put this equation or put this value in equation 3. So from equation 3, 4C is 4. We are replacing E there. So this implies C is 1. This implies C is 1. So let's observe we found A and D here, B, C and E over here. So we found all the 5 variables. So yes, this is a type of questions which are asked. I'll show you 1 or 2 more questions of the same category. Majorly, you can understand every year there's 1 question of this type. So because we've done 2 examples completely in detail, I'll be leaving those 2 examples as your homework. Okay, I think we have it. Okay. Sorry. May 2023, again, 5 marks question. A, B, C, D, E. Again, f of z is given as analytic. Process will remain the same. You're expected to use Cauchy-Riemann equations and compare the coefficients and find the value. Okay. I hope you will be able to do this question on your own. So I'm leaving this question as a homework or your practice question. Right? Okay. Moving on to the next category of questions now, which have again repeatedly appeared in the paper. Second type of question, determine the analytic function whose real part is given to you. So here the real part is given to you and they're asking you to find the analytic function. So let's understand the concept here and we'll solve examples based on this type. Okay. The question has given you the value of u, that is the real part. Again, the concept of Cauchy-Riemann is going to come into picture. So I will have to calculate ux and uy. As before, ux will be partial derivative with respect to x and uy will be partial derivative with respect to y. While calculating ux, x will be the variable, everything else will be constant. While calculating uy, y will be the variable, everything else will be constant. So cos y is a constant and derivative of e raised to x is e raised to x itself. So no change here. While calculating uy, ex is a constant, derivative of cos y is negative sin y. So this becomes negative e raised to x sin y. Okay. Now let's understand. We have this relation for the derivatives. You have f dash of z is given by ux plus ivx. You have f dash of z given by ux plus ivx. Now, because I don't know v, I don't know vx, but I do know that by Cauchy-Riemann equation, I know by Cauchy-Riemann equation, vx will be equal to negative uy. Okay, we wrote uy is negative vx, so this time vx is going to be equal to negative uy because we want vx in the terms of uy. Is this okay? So now, once we got these values, I'll replace it back in f dash of z. So now my f dash of z is going to be ux minus I times uy. We are replacing vx with negative uy. Okay. Now let's see, we have both the values ux as well as uy. So let's substitute the values here. Ux will be replaced by e raised to x cos y minus I times negative e raised to x sin y. So this gives me e raised to x cos y. The negative term will become positive because of the double negative. Okay. So this is what we got it here. The question is asking us the analytic function. So basically the question is asking us to find f of z. The question wants you to find f of z. We have found f dash of z. So when we know the derivative, how to find the function, we need to integrate it. Now, there is a special technique to integrate in the topic of complex numbers. That technique is called Milne-Thomson method. Let's understand the Milne-Thomson method. Whatever f dash we have got, it is in terms of x and y. Whatever f dash we've got, it is in terms of x and y. Let me copy it here. So we've got e raised to x cos y plus I times e raised to x sin y. Now when I apply Milne-Thomson method, the method says f of z, okay, f of z, we have f dash. So f of z will be written as f of z comma, or yeah, f of z will be written as integration of f of z comma 0. Now understand what does this notation means? It means in this equation where we have x and y, we will replace x as z and y as 0. So when I do that, my e raised to x will become e raised to z cos 0 plus I times e raised to z sin 0. And whatever I get will be integrated with respect to the variable z. Now let's simplify this. This becomes e raised to z cos 0 is 1. I times sin 0 is 0. So the second term vanishes. We are left with integration of e raised to z dz. And we know integral of e raised to z is nothing but e raised to z. And of course, we'll add the constant of integration. So this is the required analytic function. I hope the question is clear with everyone. Let's look at the next example. Similar example in the same category. The question is again asking you to find the analytic function written as u plus iv, where u will be the real part because it does not have I, and v will be the imaginary part. Okay. The question has now given you v rather than u. Previous question had given you the real part. U was given to you. I can show you the question again. Okay. And here v is given to you. So that's the difference in the question. Now see, this was an 8-mark question. The previous one was a 6 marks question. So of course the calculation will be a little longer. Everything else is going to remain the same. The flow chart or the steps are going to remain the same. So as v is given to me, I'll start with v here, the imaginary part. And we start with vx and vy. So let's begin with vx first and then we'll go to vy. Again, while calculating vx, x will be the variable, everything else will be constant. Derivative of x square is 2x. Derivative of y square, which is alone, will be 0. Now the derivative of the second term or the third term right now will be in the form of u by v rule of derivatives. So that's v derivative of u minus u. While taking derivative of v, there are two terms. One is x, one is y term. So only the x term will give derivative. The second term will give 0. So 2x plus 0 divided by the entire denominator square. So let's simplify this. This becomes 2x plus x square plus y square minus 2x square upon x square plus y square the whole square. This becomes 2x plus y square minus x square. There are two terms with x square. We have subtracted them. And so x square plus y square the whole square. Okay, so this is your Vx. This is your Vx. Let's calculate Vy. So to calculate Vy, I'll just note down V again here. That was x square negative y square plus x over x square plus y square. Let's calculate Vy. Now y will be the variable, everything else will be constant. So 0, negative 2y. Second term, you can find the derivative in two different ways because we have used u by v before. We'll continue with the same. So v derivative of x where y is a variable, so it will be 0 because x is a constant, okay? Minus x times derivative of the second part with respect to y. So 0 plus 2y. So this is x square plus y square, the whole square. Now we are left with negative 2y. The first term is 0 and negative 2xy divided by x square plus y square, the whole square. This is Vy. Now it's given to us that f is analytic. Also, we are expected to find f. So we started the formula of f dash like we did last time. F dash of z over here is equal to ux plus ivx. We don't know ux, so we'll use Cauchy-Riemann equations. So since f of z is analytic, by Cauchy-Riemann equations, we claim that ux is equal to vy. That is your first Cauchy-Riemann equation, which implies f dash of z over here will be vy plus ivx. Vy plus ivx. Okay, so let's use this and write down f dash of z. So f dash of z over here, which is vy, we got vy over here, negative 2y, negative 2xy, divided by x square plus y square, the whole square, plus I times Vx, correct? So Vx over here is 2x. So we'll put a bracket because of the I. Okay. Y square minus x square divided by x square plus y square, the whole square. Now again, we have found only the derivative of f, not f itself. So to find f, we will again apply Milne-Thomson method. And before that, I may write this as f dash of x comma y. So while applying Milne-Thomson method, as we did in the previous question also, you will replace x by z and y by 0. So you will have f of z is integral f dash of z comma 0 dz. So let's substitute the values. You are expected to replace x with z and y with 0. So the first term is 0 because of the y there. Second term is also 0 because of the y present there. Third term becomes 2iz. Okay, whichever term is multiplied by y will become 0. The fourth term is 0 minus x square. Oh, sorry, x will be replaced by z. Divided by z square plus 0 the whole square. And this entire thing I have to integrate with respect to z. So I have an integral of 2iz minus z square over z raised to 4. This is z square the whole square which is remaining dz. Now to integrate this from the first term, 2y is a constant, comes out of the integral. I have integral z dz. And second term, the powers will get cancelled and have negative integral of z raised to minus 2 dz. So this is 2i z square over 2 minus z raised to minus 1 over negative 1 plus the constant of integration c. First term 2 gets cancelled. I am left with iz squared. Here the minus gets multiplied and you get 1 over z. Z raised to minus 1 is 1 over z. So this is your required analytic function. Now this was a 8 marks question. So yes, you could see that the calculations were a bit lengthy. There was u by v rule and things like that. Okay. So this is a second category of questions where either u is given or v is given. We will now look into the third question in the same category. You can see again the question is to find the analytic function f of z, which is u plus iv format. And now look at the difference in the given thing. Previously, we were given for the first question, u was given, the real part. Second question, v was given. Now in the third question, u plus v is given to you. Okay, this is again a question in the university papers. It has appeared in May 2023 for 6 months. So first and foremost, if you observe, there's a correction I have cancelled and written there. So there's a correction in the question there. So that correction needs to be noted, first thing. Okay, let's simplify the numbers here. And let's simplify the question first before we start solving. So I have u plus v is equal to 2 sine 2x divided by, now observe here, we have e raised to 2y plus e raised to negative 2y. If you remember, we have this formula e raised to 2, or you have basically for e raised to theta. Okay, e raised to theta and e raised to negative theta when we have divide by 2, we say it is cos hyperbolic theta. So whatever is the angle in place of theta, that goes with hyperbolic. And if you observe, what you have here is e raised to 2y plus e raised to negative 2y. We don't have a upon 2, so this upon 2 can be cross multiplied. So 2 times cos hyperbolic theta is replaced by 2y. So that's what I'm going to do here. Denominator will be written as 2 times cos hyperbolic 2y, the first two terms, and negative 2 cos 2x, the last term. Let's take the 2 common from numerator and denominator, or we can divide both by 2. You are left with sine 2x, cos hyperbolic 2y, and cos 2x. Okay, so that's the value of u plus v. Now, once we got u plus v, as usual, we'll be going to partial Riemann equations. And for that, I require partial derivatives. So I'll start with ux and vx. Means basically I'm differentiating partially LHS and RHS with respect to x. We'll apply u by v rule. So v remains the same. Derivative of sin x would be, sin 2x would be 2 cos 2x minus sin 2x as it is. Derivative of the denominator with respect to x, the first term will be 0. And the second term would give me a negative, there's already a minus sign, and I'll have a negative 2 sine 2x. And the entire thing divided by the denominator square. Now let's simplify this. Let's open the bracket. I have 2 cos hyperbolic 2y minus 2 cos square 2x. We have 3 negative signs, so that's going to remain as negative, and we have 2 sine square 2x. The denominator will have a whole square still. The second and the third term in the numerator, if minus 2 is taken common, we'll get cos square theta plus sine square theta, which is 1. So we are now left with 2 cos hyperbolic 2y into cos 2x. That was your first term. Minus 2 into 1. Okay, this is how we have. And we have cos hyperbolic 2y minus cos 2x the whole square. Okay, we cannot simplify this further. So this is ux plus vx. We leave it as equation number 1. We'll again be differentiating u plus v partially with respect to, so let me call this as equation star. So I'll be differentiating u plus v with respect to y now partially. Okay, so differentiating equation star partially with respect to y now. What does it gives us? Uy plus vy on the left hand side. Again, u by v rule can be applied, or there's another method. I don't want to get into that now. Okay, so when I apply u by v rule, I'll have v, that is this, derivative of u again with respect to x, sorry, with respect to y. So there is no y term, hence the derivative will be 0, minus the numerator as it is. Derivative of the denominator with respect to y. So derivative of cos hyperbolic is sine hyperbolic. And because we have a double angle or angle as a multiple, that chain rule we'll get a 2 here. And derivative of cos 2x will be 0. The entire thing divided by cos hyperbolic 2y minus cos 2x the whole square. Okay, this is because you have derivative of u by v is v derivative of u derivative of v divided by v square. Okay, so the first term is entirely 0 because of multiplication by 0. The second term leaves me with negative 2 sine 2x sine hyperbolic 2y, and you still have the denominator with a square. Okay. Now, on the left hand side, we'll be applying Cauchy-Riemann equations. So, uy will get replaced with vx, negative vx. Okay, I write this here, negative vx, and vy will get replaced with ux. Okay, so we have applied Cauchy-Riemann equations here. And we have replaced these values. Let me call this as equation 2. Now, if you remember, we require for calculating f dash of z, I'll take it on the next slide. To calculate f dash of z, the formula which we had was ux plus ivx, which means I require ux and vx. We have two equations in ux and vx, so let's solve them. So the first thing I'm going to do is add, because when I add equation 1 and 2, I'll get 2ux. Okay, so I'll have 2ux on the left hand side. Let's look at the addition. The denominator is exactly the same. So I can directly add the numerator. No change in the denominator. So let's look at the numerator. The first term is 2 cos hyperbolic 2y cos 2x minus 2, and this remains the same. No change. Okay. Once we have got it so far, I may divide by 2 on both the sides, and I'll get ux is equal to. So dividing by 2, we the right hand side over here, all the 2's will vanish. Cos hyperbolic 2y cos 2x negative 1 we'll get here. Sin 2x sin hyperbolic 2y, and the entire thing now gets divided by cos hyperbolic 2y minus cos 2x the whole square. Okay, sorry for the space thing. Okay. We found ux, we need to find vx. Now, if you observe equation 1 and 2 left hand side, to find Vx, we need to subtract the two equations. So let's subtract the two equations. So we'll do equation 1 minus equation 2. And that will give me 2Vx. Let me erase this, we'll write it a little later. Okay. So we find the 2Vx here on the left hand side, and the denominators are the same, so we'll just copy down the denominator here. No change. So there's the denominator here. The first equation as it is, cos 2 cos hyperbolic 2y and 2 cos minus 2. Second equation, we have to subtract, means the negative 2 times will become positive now. So this will become plus 2 sine 2x into sine hyperbolic 2y. Okay. And to find Vx, we'll be dividing again by 2 and we'll get cos hyperbolic 2y cos 2x minus 1 plus sine 2x sine hyperbolic 2y. The entire thing divided by the denominator as it is. So cos hyperbolic 2y minus cos 2x, the whole square. Okay. We found these values. Let's go to f dash of z. F dash of z would be ux plus ivx. And when we apply Milne-Thomson method, we will be replacing x by z and y by 0. So we get f dash of z comma 0, which will be equal to u of x z comma 0 plus I of z comma v z comma 0. So let's simplify and find that. So when I put 0 here in place of y, the first term has cos hyperbolic 2y, which is 1. Okay, cos hyperbolic 0 is 1. Then we have cos 2z, it will be. Okay. Then we have a minus 1, which will remain as it is. Sine hyperbolic 0 will become 0, so the entire second term becomes 0. The denominator is same here, so cos hyperbolic 2y will become 1. And this will become 1 minus cos 2z, the whole plus I times Vx. Vx is here on the screen itself, just above. Again, cos hyperbolic 2y will become 1. 1 into cos 2z here. Minus 1 as it is, the second term becomes 0. Here again, the denominator is the same, 1 minus cos 2z, the whole square. Okay. Let me just... Okay. So we are going to carry it forward here. We don't want f dash, we want f of z. And before that, we'll just simplify this f dash. The denominator is the same. We have 1 minus cos 2z, the whole square. And the numerator is cos z minus 1. So, can I write the denominator, or rather, I can write the denominator as cos 2z minus 1, the whole square, because negative number, even if you flip inside the square, it's okay. The square is going to remain positive. And the numerator now has cos 2z minus 1 in the first term, as well as the second term. When I take it common, I will be left with 1 plus I. I'll be left with 1 plus I. Okay, you can see this. Here, if I take this first term and this common, the first term leaves a 1 and second term leaves a I. So now observe the numerator and denominator are exactly the same. So I am now left with 1 plus I divided by cos 2z minus 1. The square gets cancelled. And cos 2 theta, 1 minus cos 2 theta is 2 sine square theta. But it's reversed, so we have a negative. So we have 2 sine square theta, which is going to be z, and because we're integrating, it is going to become negative 1 plus I over 2 cosec square z. This is f dash. This is f dash. We are yet to find f. Okay. So to find f, we will now be applying integral on both the sides. Let's apply integral on both the sides. So I'll continue here. F of z would be equal to integral f dash of z dz. Okay. So that's going to give me that's going to give us integral of, okay, let's take the constants out. Negative 1 plus I over 2 integral of cosec square z dz. Okay. So the integral over here now becomes negative 1 plus I over 2 cot z. And there'll be a constant of integral, which is c, and yes, it's negative concept, so we'll have a plus here. Okay. So this is your required analytic function. This is our required analytic function. I hope the techniques are clear. Fine. So we have done 2 categories of questions so far. The first category was where we found A, B, C, D, E, whichever applicable. Okay. That was pure application directly of the Cauchy-Riemann equations. And the second category of questions were where we found the analytic functions provided either the real part or the imaginary part or U plus V was given. The questions are not yet over. We will be doing other questions in the next video because I don't want to make the video very long. So we stop here and we continue in the next video.